Welcome to this explainer, where we are going to tackle the Cambridge IGCSE Physics 0625 paper by doing something just a little bit different today. I want you to think of yourself not just as a student sitting at a desk, but as a paleontologist. Seriously, because today we are going to be digging deep through the fossil layers of actual, real-world question parts to reconstruct the perfect top-scoring answers. Okay, let's dive right into this. We're looking at a real Cambridge physics past paper question, specifically dealing with the reflection of light, plane mirrors, and angles. Now, I know what you're thinking. This might look incredibly straightforward on the surface, but just like digging for fossils, the real value, the real treasure, lies beneath the surface, in exactly how you systematically piece the fragments together. By the end of this explainer, you are going to understand exactly how to approach these questions, not just as a panicked student rushing against a clock, but you're going to start thinking exactly like a senior examiner who holds the mark scheme in their hands.
Let's start with a really surprising insight right off the bat, straight from the principal examiner report. It states explicitly, and I quote, "Reflection of light is one of the most misunderstood areas in physics." Now, you might be sitting there thinking, wait a minute, reflection? There is no way. That's literally just drawing straight lines and a mirror. How hard can that be? But listen, that is exactly the trap. This is a foundational topic, something you've probably looked at since your earliest science classes, yet it is a massive, massive pitfall for students who rely on generic, rote-memorized answers. Examiners report year after year, paper after paper, that candidates fail because they memorize basic rules, but completely misunderstand the conceptual framework and the procedural application required to actually score marks. It is not just about knowing the facts, it's about proving you know them in the exact way Cambridge wants to see them. And we are going to fix that disconnect right now. So here is our roadmap today to guarantee you hit those top marks. We'll start with Section 1, the challenge, where we see where students go wrong. Then Section 2, core theory. Section 3, the method mark strategy. Section 4, top warnings directly from examiners. Section 5, an interactive workshop to test your skills. And finally, Section 6, the final system. Let's get moving.
Section 1, the challenge. To truly understand how to win at this game, we first have to understand exactly how students lose. We often see two very distinct types of candidates who consistently struggle in Cambridge examinations despite putting in hours and hours of revision. Let's call them Alex and Sam. We are going to look at their approach to a classic reflection question to identify exactly where the breakdown in methodology actually occurs. Comparing these flawed answers side by side, the contrast is incredibly revealing. On the left side of your screen, we have Alex. Now, Alex overloads the paper with raw physics facts, but provides absolutely zero analysis. If the question asks to evaluate a reflection scenario, Alex panics and simply writes down every single definition they've ever learned about light, hoping something sticks. But here's the secret. The assessment framework prioritizes analytical depth over superficial breadth. They don't want a textbook vomit. They want applied knowledge. Then, on the right side, we have Sam. Sam rushes the answers and completely misses the command word requirements. Sam might see the word mirror in the prompt and immediately sketch a generic diagram without ever noticing that the command word was actually compare or explain. So the crucial takeaway here is this. It is abundantly clear that simply knowing the physics isn't enough if you lack the structural strategy to format your answer exactly how the examiner requires. You are basically leaving marks on the table.
Section 2, core theory. We need to lay the groundwork before we start building the house. But before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's establish the fundamental theoretical architecture required for these reflection questions. Remember, referencing accurate cross-topic connections here is what actually pushes you up into those higher grade boundaries. The theoretical foundation for absolutely everything we are talking about today begins with the normal. This is a construction line drawn perpendicular, meaning exactly at a right angle, 90 degrees, to the reflective surface right at the exact point of incidence where the light hits. Listen to me on this one, it is not just a dashed line you throw in if you have extra time. It acts as the critical, absolute anchor for all of your angle measurements. A massive, heartbreaking mistake students make every single year is drawing the normal arbitrarily, just wherever it looks nice, or measuring angles from the mirror's surface itself instead of this line. Whenever you see a plane mirror question on that paper, your immediate automatic physical action must be to take your ruler, put it on the paper, and identify or construct this perpendicular normal line. It is the absolute reference point for the entire problem. If you get the normal wrong, the rest of your answer crumbles. Building on that crucial anchor, we have to precisely distinguish the angle of incidence from the angle of reflection. The angle of incidence is the incoming ray measured specifically to the normal.
The angle of reflection is the outgoing ray, again measured specifically to the normal. The absolute most essential, non-negotiable rule to perfectly identify and apply here is that the angle of incidence always equals the angle of reflection. Memorize it right now. I equals R. It's that simple. But, and this is a huge but, remember that examiners are actively going to try to trick you. They will try to bait you by giving you the angle between the incident ray and the mirror itself, not the normal. You have to use your logical, structured reasoning to catch that trick, subtract that given angle from 90 degrees to find the true angle of incidence first. Do not fall for that trap. Now, to complete your theoretical architecture, you must fully memorize 3 unchangeable properties of an image formed by a plane mirror. 1. It is virtual. 2. It is the exact same size as the object. And 3. It is the same distance behind the mirror as the object is in front of it. Let's pause on that first one. What does virtual actually mean in physics? It means the light rays don't actually physically meet at that point behind the mirror. Our brain is just playing a trick on us and extrapolating those diverging rays backwards behind the glass. Because of this, you cannot project a virtual image onto a screen. Examiners absolutely love to test your conceptual framework here by asking you to apply these 3 exact properties to complex, real-world scenarios. If you don't have these locked in your memory, you simply cannot build your analysis. Section 3. Method mark strategy. Okay, knowing those definitions we just covered is only step 1. Now we need to translate that theoretical knowledge into actual tangible points on the board. In Cambridge Physics, you are rewarded heavily for your systematic processing. We are going to look at a standardized sequence and a specific framework to ensure your precise application earns marks every single time. And the best part? This works even if you panic and make a tiny calculator error at the very end. Take a look at this 5-step standardized sequence. This builds a professional procedural framework and shows you exactly what examiners are trained to look for. Step 1, identify key elements. This is as simple as spotting the mirror, the light ray, and identifying the command word. Step 2, apply relevant principles. Literally write down the formula I equals R on the page. Step 3, execute analysis with clear working. Physically draw the normal with a ruler and carefully measure the angle. Step 4, verify your results. Take a step back. Does the reflection angle actually look visually equal to the incidence angle on the page, or did you make a geometry mistake? Step 5, present an appropriate format. Use the correct headings, the correct scientific terminology, and clear annotations. When you follow this exact flow, you are literally scooping up method marks left and right because you are demonstrating clear, evidence-based reasoning. The exam board rewards the process and your systematic thinking just as much as the final answer at the bottom of the page. Now let's put this theory into practice with a quick, real-time mental challenge. I want you to take a moment and look at the screen to spot which of these answers successfully connects theoretical, cross-topic concepts using the PEEL framework. For those who don't know, PEEL stands for Point, Evidence, Explanation, Link. The PEEL framework is brilliant because it forces you to evaluate the quality of your evidence. You make a point about the reflection. Then, you provide hard evidence directly from the diagram given to you. You write an explanation using core physics principles, like stating I equals R. And critically, the step most students miss, you link it back to the specific context of the question. Let me give you an example. The candidate who just scribbles, it reflects, gets absolutely 0 marks for explanation. But the candidate who writes, the angle of reflection is 40 degrees, that's their point, because the diagram shows an incident angle of 50 degrees to the mirror, meaning the angle to the normal is 40 degrees. That's the evidence. And the law of reflection states I equals R, there's the explanation. Therefore, the outgoing ray will precisely hit target B, boom, there's the link. That candidate gets full marks every single time. Section 4, Top Warnings. We are now going to look at the absolute most critical warnings directly from the grading floor. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, pulling back the curtain here, derived directly from the principal examiner reports, we can map out the top 3 devastating mistakes that destroy your chances of a perfect score. Rank 1. Missing proper format. This means failing to draw the normal, or frankly, just being lazy and not using a ruler for your light rays. The impact? An immediate, unnecessary loss of easy procedural marks. Rank 2. Not checking presentation. This leads to poor clarity. Listen, examiners are marking hundreds of papers. If they cannot clearly see where your angle arc starts and where it ends, they simply cannot and will not award the mark. Rank 3. lack of context. This is a fatal flaw. This is where the student fails the assessment benchmarks entirely by not applying the physics to the specific scenario requested. They write a beautifully accurate, generic textbook answer instead of actually analyzing the specific data provided in the prompt. To drive this home, the examiners explicitly warn us with this quote: "The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario." Top-scoring candidates, the ones getting the A stars, demonstrate true evaluative thinking here. They don't just vomit physics facts onto the page. They take the core physics principles of plane mirrors and they bind them directly, tightly, to the specific setup of the question. Let's say the question is about a periscope in a submarine. Your answer absolutely must reference the periscope. It must reference the specific angles inside that specific submarine setup, not just regurgitate the general laws of reflection. You have to identify similarities and differences strictly within the context provided. That is what evaluative thinking is. Section 5. Interactive Workshop. It's time to test you. Let's actively transform those figurative red pen marks we talked about into beautiful green check marks. I want you to actively engage with this next challenge. We're going to scan some data and fix a flawed sample paragraph together. Let's see if you can spot the exact error that would cost a student their marks. Look very closely at the screen. The student's sentence states, "The image formed by the plane mirror is real, the same size, and the same distance." I'll give you a second. Do you see the flaw? The crucial error, the one that is literally bleeding marks right here, is calling the image real instead of virtual. Now, the student correctly identified that it's the same size and same distance, showing they did some revision, but by calling it real, they have fundamentally misunderstood the very core physics of plane mirrors. A real image means that light rays actually converge at that physical point in space, which they absolutely do not do behind a solid plane mirror. It is virtual. By just swapping that one single word, you upgrade the answer from a flawed, generic attempt to a mathematically and scientifically precise statement that easily earns the full mark from the examiner. Section 6. The final system. Now that we have successfully dug through the question layers, decoded the common traps that catch so many out, and reconstructed the theory step by step, it's time to pull this whole operation together. We are going to build the ultimate strategy for your next physics paper. Here it is, your physics success blueprint. By strictly following these 3 golden rules, you guarantee yourself top marks because you actively avoid superficial breadth and prioritize the analytical depth examiners crave. Rule 1. Command word decoding. Stop rushing like Sam. Always identify what the verb is asking you to do before you pick up your pen. Are you being asked to calculate, to define, to explain, or to evaluate? They all require entirely different answers. Rule 2. Peel framework application. Structure your written long-form responses with point, evidence, explanation, and link. This ensures you systematically hit every single requirement the marking scheme is looking for, especially that highly prized contextual link. Rule 3. Time management matrix. Allocate your time based specifically on the method marks available. Please do not spend 10 agonizing minutes perfectly sketching a 1-mark normal line, but absolutely do take the time to clearly, neatly lay out the 5-step procedural framework for a complex multi-mark calculation. So, what does this all mean? Why does all of this incredibly detailed strategy actually matter? 2. That is the number of full grade boundaries students see in average improvement when they stop treating the exam like a memory test and start implementing these exact physics strategies. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. It comes down to perfectly utilizing that normal line, avoiding the generic context traps we discussed, and flawlessly structuring arguments with the Peel framework. That is literally the difference between sitting at a B and walking away with an A star. It happens simply by understanding the psychology of the exam board and presenting your hard-earned knowledge in the strict conventions the examiners demand. The next time you sit down in that exam hall and are faced with a seemingly simple question about a mirror, I want you to ask yourself, are you just reacting with memorized facts like Alex? Are you rushing the command words like Sam? Or are you acting like a calculated senior examiner? The difference between a passing grade and perfect marks lies entirely in mastering this system. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment.
Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here.